Hello everyone, and in this video we're going to learn how to compare distributions. So comparing distributions is usually when we're given two different sets of data. Now this can be in various forms such as tables, box plots as you see here, stem and leaf plots, or even bar graphs, histograms, or just bell curves. And what we're really asked to do is that we're asked to compare these distributions. Now, describing and comparing are very different. Usually, when we are asked to describe a distribution, we just want to list the factors. But when we're asked to compare distributions, then that is a totally different topic, and that's what we're going to learn today. Now, this is a skill that we all should have because usually in the real world, when we're given two different sets of data, we want to be able to analyze and compare them properly so that we can recognize patterns, outliers, or even deviations from those patterns, and we want to be able to identify those with ease, which is why we will be reviewing that topic in this video. So here we are asked to compare the distributions of weights for males and females. As you can see, the box plots are provided for both these genders. And you may think that this is a very qualitative graph here. Even though there's numbers, we don't have concrete measurements and values, especially because we're dealing with only medians here, since box plots usually display medians in their second quartile and not mean. So that would be something different today. So we're going to go ahead and start off with listing the things that we need for distributions. So we want to describe our shape, our outliers, our center, and then we want to make sure we include spread. And as you can see here, the acronym SOX helps us remember the 4 key ideas we need when we are comparing the different distributions that are provided. So let us begin. So for the shape, we can say that both of these are unimodal. And what does that mean? Well, that just means that they are just a single peak. We don't have two distinct peaks here. This is a unimodal graph. This would be bimodal. Here we can see there's only one median, so this would most likely be a unimodal graph. So here we can say that both the distributions of weights, and we want to make sure we're referencing units as well, and we make sure we look at all the labels of the graph. So both the distributions of weights for males and females are unimodal. And we can also include skewness here. When we're talking about shape, we're not only asked about the different types of peaks, such as unimodal or bimodal, but also the skewness. And here, since the median is roughly in the middle here, when we look at this whole box plot, we can say that both of these are roughly symmetrical. We don't want to say that they are exactly symmetrical because that would be an assumption that we don't necessarily know, but these are just roughly symmetrical. So our unimodal and roughly symmetrical. So here we have covered the shapes of both the distributions. And now what we want to do is we want to talk about outliers. Now, outliers don't necessarily need to be specific points. They can also be deviations from the current pattern we see. Usually in box plots, outliers are represented by like a dot or a box. So I know it's not here, but maybe it could be something like this, or maybe like that, or a dot. These are just different symbols you may see on a graph. But here in this box plot, there are none. So we can say we can say that none of these distributions have outliers. So none of the distributions contain outliers. So now we can go ahead and talk about center. And if you want, we can just check off the list that we have described both of these. Center and spread are left. So center doesn't have to be the average or the mean, which is what most people think. It can also be, remember that there are various measures of center, so it can also be the median here. And that's what we're really, that's what we really know in this box plot. So talking about the mean wouldn't necessarily be the best measure of center here. We would really talk about the median because remember our quartile 2, that is the same thing as our median, which is displayed by this bolded vertical line here. So we can say that we need to compare the centers. So even though we don't know concrete numbers, we can kind of make out that this is around, let's say like 165, because this would be 170, so about 165 here. And then the median for females would be around 120. So we don't necessarily have to include these values. We can just say that the center, the median for the weights of males is greater than the median weight for females. So we can go ahead and include that. So the median weight in pounds for males, and you can include the median if you want. You can include, we can say approximately 165 pounds. Make sure to include approximately because we don't really know what the actual value is greater than the median weight for females. And then again, this is in pounds, and it's going to be approximately 120 pounds. And really, this is where our comparing comes in. The fact that we're using words such as greater than, we can say both, none. The fact that we're using these reference words really tells the reader or the graders that we are comparing these distributions, not just listing the facts. So now we have spread left, and for our spread, we are going to describe variability here. So here we can variability or standard deviation. So as you can see, the box plot is very spread out for the males. Since these are both roughly symmetrical and the median is here, we can infer that the mean and the median would lie around the same values. So here, since this would also be close to where the mean was, you can say that these values are very spread out from the mean compared to for females, which is very little compared to that of males. So we can say that the variability for weights of males is much greater than the variability of weights for females. And we can see that by the ends of these lines here. We know this is our quartile 2, quartile 3, and the fact that there are so many other values that deviate greatly from the mean indicates a higher variability. So here we can say the variability of weights for males is much greater than that of females. And here we checked off a measure of spread because we're talking about variability. And this is a very common misconception that people have, that when we're talking about spread or center, there's very fixed measures like mean or standard deviation. But in reality, we want to be describing what we know from the graph or data we are provided. And here, median would obviously be the best measure of center to talk about. And variability is also very easily indicated as these box plots provide us with. So the variability of weights for males, we can safely say is much greater than that of females. And here we are done comparing the distributions of weights for both the genders. And as you can see, this is much different than just listing the facts for males and listing the facts for females. We're really integrating these two graphs together and analyzing the patterns, trends, or even deviations from those patterns we see here. And that is what comparing distributions is all about. So I hope you learned something from this video. If you did, please give it a thumbs up. Be sure to subscribe, like, and comment if you have any questions. And I'll see you next time. Bye.